to become a forward operations specialist because we need like 50 dudes in the next 3 months.
Weather manipulation is on everybody's mind right now, and you make it rain, so
Then we'll launch our drones up into it. The drones that we've built are the only ones in NATO that are under 55 pounds. It's actually way easier to make snow than it is rain.
why is that?
All startups think about how Elon blew up 3 rockets before he actually launched one into space. Like, we had a lot of drones crash. Rainmaker and cloud seeding mimics this natural process where you get in excess of 40 million pounds down on the ground. 40 million pounds of water.
Let's talk about how this all works.
Okay.
How does it work?
You have water in clouds, right? I'll walk you through the form of the tech that we understand very well, and then a proposed alternative way. You have water in clouds. 80% of precipitation-ish that occurs on the planet happens because you have water in clouds, and then you have natural dust, or you have bacteria that gets kicked up from the soil, all natural stuff, that the water freezes onto, turns into big heavy snowflakes, and then falls, either stays as snow or melts into rain, right? Rainmaker and cloud seeding mimics this natural process where you have water in the clouds, but the droplets aren't big enough and heavy enough to naturally precipitate. If you put material in the cloud that has a crystal structure similar to ice, then the water will freeze onto it, grow into those big snowflakes, and fall. That's sort of like the high level, but the system that Rainmaker uses has a few other important components. So first of all, you have to be able to detect whether a cloud has enough liquid, because if the cloud is mostly ice, then you can't freeze much more. But we use radar to measure how much liquid is in the cloud. The way that we do that is one wave of the radar moves vertically, right? And then the other is oriented horizontally. So you get the amount of the beam that is reflected in both directions. And so if you have about an equal amount of the horizontal and vertical beam reflected, then you have a spherical target. So it's probably a water drop, right? If you get more of one versus the other, then it's probably more oblong and like a snowflake or like an ice crystal. So we can use the radar to measure where the liquid water is in the cloud. If we find that, then we'll launch our drones up into it. The drones that we've built are the only ones in NATO that are under 55 pounds that can survive in severe icing conditions. Because this is really cold water, right? So we have these resistors inlaid onto the vehicle that melt the ice off as it accretes onto the drone. So you find the water with the radar, you fly your drone up into these conditions, hope that it survives. You disperse the material. So we have this aerosol dispersion system that basically just emits individual particles that the water freezes onto. And then with the same radar you found the water with, you can now see it freezing, growing into bigger snowflakes, and then eventually bigger drops, and measure how much precipitates downwind.
So you're essentially introducing some type of an agent that has weight to it, and that's pulling the water down.
You're introducing an agent that the water freezes onto, and then it's just the weight of the water that pulls it down. So for every pound of this that you put up, you get in excess of 40 million pounds down on the ground. 40 million pounds of water.
40 million. Wow.
Yeah.
How many drones does it take to do this?
Like 3.
That's it?
So what we do is we juggle them. So one drone will go up. Once that reaches altitude, the next drone will go up. The first drone, after dispersing its full payload, will come down, and you'll just cycle that as long as the conditions persist. So sometimes that means, you're out there for 2 hours. Our forward operations specialists, though, it's a lot of former vets, National Forest Service guys, oil roughnecks, people that are willing just to live out on a mountain for 9 months at a time. Speaking of which, apply to rainmaker.com/careers to become a forward operations specialist, because we need like 50 dudes in the next 3 months. But they can stay out there for like 4 days at a time, just taking shifts, operating day and night. Because you can have an atmospheric river that will last for days.
How big of a I mean, how exact can you pick a location to have it rain on?
So I cannot make it rain over the house of your enemies. We are not precise enough to target some individual person's house or something like that. We're not even precise enough to target an individual farm. So we're talking about 100 to 500 square miles at a time. In certain cases, up to like 1,000 square miles at a time.
Sorry, go back. So the smallest would be
The smallest would basically be like an average size city.
okay.
An average size city, the watershed of a hydroelectric dam, something like that. So the smallest would be that sort of scale, like municipal sizes.
Let's talk about the first time you did this,
Yeah.
where you made it rain.
Yep.
Just walk me through that scenario, that experience.
Well, I'll tell you, first of all, we failed way more times before we actually accomplished it. We crashed a lot of drones. We did not have the system to actually target liquids, so we were flying into clouds that were just ice, so we couldn't affect them at all. It was it was a pretty. Everybody that's on the Rainmaker team is pretty tough for having stuck out that period. It's sort of like, all startups think about how Elon blew up 3 rockets before he actually launched one into space. Like, we had a lot of drones crash before we actually were able to make it precipitate. And so we were up in northeastern Oregon in a town called Pendleton. 16. It's where Pendleton wool is from, if you know it. It's a town of 16,000 people, 2,000 of which are in a prison. Most of the rest are farmers. So super, super small spot. We have a team of forecasters that saw that there was an atmospheric river coming in. The clouds were about 2 kilometers thick, almost all liquid. We were able to, one, finally get the radar system functional enough to measure that water, and then launch weather balloons to take in-cloud measurements of the water there. And then we were just flying drones for hours and hours. And we didn't have the processing capability live yet to take live measurements. So we were just out there operating, flying drones for a few hours. And then we pack up, go back to the warehouse that we were all living out of, look at the radar data, and then saw from the time that we started operating, about 15 minutes afterwards, this plume on the radar exclusively downwind. So this whole big cloud system wasn't precipitating, and only on the radar do you see downwind where our particle plume was, an increase in precipitation. And another thing that I guess this is an opportune time to share is there was a snow day at the local school district, 15 miles north of where we were, where the wind was going. So that was a pretty cool thing to have done for the kids there locally. It was yeah, that was back in December 12th of last year.
Wow. So you just got it done within the last 6 months.
6 months. We Rainmaker has kind of been like this, and then that, just like rapid growth trajectory since we were able to do it.
Have you been in your own rain?
Snow, yeah, our own snow. It's actually way easier to make snow than it is rain.
Why is that?
So you know how the material freezes the liquid in the cloud? Mm-hmm. That means that the cloud has to be cold enough for you to freeze it in the first place, which generally means that it's cold beneath the cloud too. Now, with respect to rain, we're operating in Utah, Colorado, Oregon, California, and Texas. It's all rain in Texas, so we've been in our own rain there. Out in West Texas and the Trans-Pecos, the Panhandle, that's been pretty cool.
Yeah, that's got to be pretty. It's got to be a weird feeling, knowing that that's your rain.
Like I said, that's the second most important thing that I've ever done in my life.
What is the agent?
Yeah, so silver iodide. That is what has been used in one form or another for the last 60 years. Its crystal structure is almost identical to ice. So that plus a couple other material properties make the water freeze onto it very well. We use so little of it, about 50 grams per 100,000 plus acres, that there's no accumulation, no measurable or consequential accumulation in the soil for humans or for farms or for ecosystems. All that being said, though, well, actually, the first point is most cloud seeding operations in the past have used flares. So they'll burn a flare that aerosolizes the silver iodide. But in the flare, there's a bunch of other junk materials, right? People get concerned about aluminum or stuff like that in the flares. So we don't use that because we don't want any additional additives beyond what is explicitly and exclusively for rainmaking. So our aerosol dispersion system just uses silver iodide. Something that we're working on right now is totally organic material found in American soil that is biodegradable, that is more effective and actually costs less per gram than silver iodide. We have a bunch of lab testing to do before we roll that out to the field, and then we need to do all of the regulatory permissions with the EPA and otherwise. But silver iodide is what we've used for the last 7 months.
When do you think you'll introduce the other agent?
January 2026.
Coming up, another 6 months. Nice. Let's talk about, some of the benefits of this, other than the obvious. What are some of the other benefits that this could bring to the world?